Yes, this is quite a complicated problem. No, it's not the end of the world. It's very doable. Now, first of all, we've got car P1, and I'm going to make it purple. P1 goes this way, and then this way. So this is P1. P2 goes just straight this way. I don't know, maybe P1 had to pick something up. What we need to do is, first of all, figure out how far they both travelled. Now, we already know how far P2 travelled, but we don't know how far P1 travelled because we don't know the line BC. So we're going to have to figure that out. And then we're going to have to figure out how long they both took because it's the one with the shortest time that got there first. So don't forget, whenever we're using speed, distance, time, we have speed equals distance over time. I'd like to remind you of a way to remember that. So speed is kilometres per hour, isn't it? Now, kilometres per hour can be written as kilometres over hours. And kilometres is distance. Hours is time. So speed equals distance over time. And that's a little bit of dimensional analysis, something that's very handy to learn if you're doing physics or chemistry. Look it up. Okay, so first, length BC. Well, we've got a non-right angled triangle. We don't have a side and its opposite angle, so we're going to have to use cosine rule. So BC squared equals 8.3 squared plus 15.2 squared minus 2 times 8.3 times 15.2 times cos 57. So BC squared equals plus 15.2 squared, take 2 times 8.3 times 15.2 times cos 57. 162.51. So BC is the square root of that, which gives us 12.75. So P1 so it went AB plus BC, so it's 8.3 plus 12.75, which gives us 21.05. So let's figure out its time. So if we know speed equals distance over time, we know time equals distance over speed. Because technically we've times both by time and then divided both by speed. But whenever you have two things and what you want is on the bottom, you swap them. Okay, so we know distance equals that. Speed, in the question they told us it was 80 kilometres per hour. So time is 21.05 kilometres divided by 80 kilometres per hour, which gives us 0.263 hours. Now, if you press the degrees, minutes, seconds button on your calculator, you can find that that's 0 hours, 15 minutes, 47.15 seconds. Okay, so now let's figure out for P2. Much easier. Distance was just 15.2. Speed, they told us it was 50 kilometres an hour. Which means it's time 15.2 over 50. So time equaled 0.304. Again, DMS button, so degrees, minutes, seconds button, that's 0 hours, 18 minutes, 14.4 seconds. Okay, so P1 arrived first, because it's only 15 minutes. If we want to know by how far, we do the bigger minus the smaller. So I'm going to go back to the fractions I put in. 15.2 over 50 minus 21.05 over 80. .040875. Again, DMS button. 2 minutes. Sorry, 0 hours, 2 minutes. .2715 seconds. So they want that to the nearest minute, so that's 2 minutes. Because 27 seconds is closer to 0 than 60. Oh, to one decimal place, 0 minutes. 2 minutes. Yeah, whatever. That's it.